Hey guys, this is Michael with Breaking Concepts, and today we're going to take a look at the proof for midpoint Jensen's inequality. So the inequality basically you can see is here, right? So you have the f of this is f, by the way, the entire function. The f of a plus b divided by 2, basically, right, the midpoint, somewhere here, right? Basically, the midpoint, right, somewhere here, is going to be greater than fa plus fb divided by 2. Okay, so we want to prove that this is the case. And the midpoint Jensen inequality is actually, the very fundamental basic of the inequality. As you progress, you can learn something more in depth surrounding probability and all that stuff. But this video is just going to be super quick, so we can just do a quick definition. M equals to a plus b divided by 2, which is our midpoint M, okay? So basically, in other words, this inequality is going to be Fm is going to be greater than our Fa plus FB divided by 2. And the only thing that we're going to use and a really important theorem that we're going to use when doing this is actually our mean value theorem. So let's kickstart with a mean value theorem over here. So if we divide the slope in 2, we would cut from the midpoint, right? So we're going to have AM. This is a slope, right? And then we have MB. Okay. Okay, so we can use the midpoint theorem, and you're going to see why we need the midpoint theorem. So let's just do if, let's say, a C1, as a point between A and M, such that F prime C1 is going to be equals to our Fm minus Fa divided by M minus A. Okay, so we're going to do some more, I don't know, I have no idea where that is, but it's called C1. And we want to do one for C2 as well. So C2 as a point between our M and B, such that our F prime C2 is going to be equals to our F, B minus Fm, and then we have B minus A. Okay, so you see the slope here is basically this one, right? You have Fm minus Fa divided by M minus A, and you have Fb minus Fm, right? Divided by B minus M. Actually, I wrote it wrong. Is M. Sorry about that. It's M. So having these two formulas, we can actually continue on by doing some manipulation. So we know that F prime C1 times M minus A is going to be equals to our Fm minus Fa. And we know that F prime C2 times B minus M is going to be equals to our Fb minus Fm. Okay, so what you're going to see here is this. And actually, we can know that, okay, because M is a midpoint, this distance is equals to this distance, okay? So we know that M at minus A equals to B minus M. But now, here's the thing. We want to take a look at C1 and C2. So that our C2 is greater than M, which is also greater than our C1, okay? And so C2 basically is greater than C1. And because this is a concave curve, right? This is a concave down curve. As we progress, we can see that the slope just kind of levels off, right? In another term, we can say that the slope is becoming less and less positive, so it's decreasing. So we can know that because our C1 is, somewhere here, it's before the C2, the slope is going to be larger than F prime C2, okay? And so, looking back into this formula, because we know that, okay, these two things are going to be the equals anyways. We don't have to look at this one. But now we do know one thing is that, okay, F prime C1 is going to be greater than F prime C2. So we know that this Fm minus Fa is greater than Fb minus Fm. So we have Fm minus Fa is going to be greater than Fb minus Fm. Here, you can just do very quick manipulation. You'll get Fm, right, times 2, because you just kind of move that over here, and you move that over here, you have Fa plus Fb. And moving on, you were going to have Fm, right, and then you can move the division to the other side, you would have FA plus FB divided by 2. And so we know that M is basically A plus B divided by 2. And so we have just proved the Jensen's inequality. Okay? So what we just proved is basically this thing. Okay, we have this thing is going to be greater than this thing divided by 2. Something like that. Okay? And this works for concave down. So I hope that makes sense to you. Thank you so much, guys.